Okay, let's recall how to recognize an ionic compound. The first way is if you look at the compound and it's a combination of metal and nonmetal. And the second way you recognize an ionic compound, if it contains a polyatomic ion. And the way we said you do this is if you look at the formula and there's more than 2 elements in the formula, you immediately go to the common ions list and see if you can find a matching polyatomic ion. Combination of metal and nonmetal. Okay. Acids, excuse me, acids in this context will be thought of as ionic. Okay? An acid, how do you recognize an acid? Recognize acids by the hydrogen on the front. Now we named acids by first naming them like ionic compounds. So the context shouldn't be too difficult. Okay? They aren't quite ionic compounds. Sometimes they are. Some of them are, some of them aren't. Kind of depends. But we can recognize them by the hydrogen on the front, at least the simple acids we're going to talk about here. All right, so let's just talk about double replacement in the general sense now. Here's what it looks like. The general sense, AB plus BC. The front part of the formula is always the positive ion, and they're going to switch places. So the front part, which is positive, has to join up something that's negative. It's just the back part of the formula is the negative part. A, if it's going to switch out, A has to go with C. I'm sorry, that should be A, B, C, D. I don't know why I did that. Really having trouble today. I shouldn't even be here, you're right. A, B, C, D. So it'll be A, D over here. A, B, C, D. A is going to go with D. And C is going to go with B. Okay. All right. So some examples now. NaCl which we dissolve in water, aqueous. Silver nitrate, dissolved in water, aqueous. We produce sodium nitrate, and silver chloride, which won't dissolve in water, so it's a solid. So here's our A and B part. Here's our C and D part. A is going to go with the D part over here. Na is going to go with NO3. And the C part is going to go with the B part. Silver is going to go with chlorine. One of the reasons I wrote this one out for you, it doesn't matter whether AD comes first or CB comes first. Okay? You can switch these around and still double replacement. Everybody with me? So if we look at this one, this becomes A, B, C, D. But the calcium we wrote first over here. So this we're going to just reverse the order. C, B, and A, D. We're getting to the last one. The last one is acid-base. Remember, that's a subcategory of double replacement. Recall that acids, at least the acids we've talked about so far in this class, have hydrogen on the front of their formula. We haven't yet talked about the fact that bases, at least the simple bases we're talking about at this point in time, the bases we're going to talk about at this point in time, have hydroxide, that's OH negative, on the back. There are other kinds of bases, and we'll get to those in the acid-base theory unit, but for right now we're going to stick with some simple, really simple acids and bases. They're called Arrhenius acids and bases. Alright, so here's an acid. If I'm not mistaken, this is still the most commonly used acid in the world. It's a tricky acid. Oh, trippy? Okay, if you say so. And any base is going to be an ionic compound with a hydroxide ion on the back. More than 2 elements, you look on the common ions list and you will find OH on the common ions list. That's hydroxide, so we're going to say that's a base. Remember, it's double replacement. We've got an AB part here, a CD part here. A is going to go with D. The hydrogen ions went with the hydroxide ions. I haven't finished balancing this yet. Actually, I got to have 2 of these and 2 of these. And then the C part, K, goes with the B part, the sulfate. And just as a kind of foreseeing, something we're going to deal with when we get to the acid-base unit, I want you to go ahead and know this. These simple acid-base reactions always produce salt and water. So for a chemist, any product of a simple acid-base reaction other than water is a salt. There's the water. That must be a type of salt. And it is. Water is H2O. Well, there's 2 H's and 1 O. Okay? That makes sense to everybody? Alright. So you all wrote down your homework before we started today, right? Okay. You got a few minutes, you can get started on your homework.